Hello everyone, I'm happy to see you again here. Today we will continue with part 3, conclusion. So in the conclusion, you were not asked to write the conclusion. You were asked to analyze the conclusion. Okay, so you were expect to use your data, okay, to use your data, and you will expect to use your theory, and you will expect to use your research. Okay, so you are going to, what you do is you are going to justify your conclusion from these 3 aspects. And in this 4 criteria, we were going to use examples to show you how you are going to justify your conclusion from these 3 aspects. Okay, so the first one and the second one is about data. So if you can see over here, first, this is closely related to the last video. We talk about data analysis. If you have not watched the last video, you may take some time to look at the very last part of the data analysis. We talk about statistic analysis of your data, right? So after statistic analysis of your data, so you should have some correlation, and then you have some outlier discuss, and then some kind of deviation, and you should be able to have a trend or patterns, okay, or patterns. Example would be, we're using this as in the previous example as well. So if you cannot see the trend over here very clearly, but you can see it's kind of like exponential trend, right? Exponential trend. And then if you wanted to do a further analysis, and you also need to do some linearization to make it into a straight line, and then talk about the uncertainty and talk about the reliability of your conclusion, right? You could do it on the data analysis, or you could do it on the conclusion. There is no very clear boundary what this part should belong to, okay? But this is an essential part of your report. We could have some further example like this one. Like this one over here, talking about the trend and talking about the equation, talking about correlation, right? Correlation, and talking about deviations, and also talking about linearization and what would be the possible axis or function between x and y, and those are the first criteria or first part of your justification. Okay, use your data and use your uncertainty and justify your conclusion. Number 2 over here, if you have like wanted to get a 4 mark, or you wanted to get a 7, and then there's even like more discussions that you could done on your data, right? Other than some very essential and basic one, you could also talk about the reliability. As we say, talk about reliability can be using uncertainty. Just write it here: reliability. Right? You could talk about this from your uncertainty. This is the one we talked about before. Or you could talk about this through the limitation, okay, limitation of your data. So this is a kind of challenge, but you could try. I'm going to show an example over here, and you can see how this example is using limitation of the data to talk about the reliability. It is an example of measuring the internal assessment, okay, internal resistance of the battery, internal resistance of the cell. Okay, we have the experiment in the syllabus. Okay, so basically he can use two set of data to get internal resistance. Okay, small r, internal resistance. So if he used the first graph, okay, which is r and reciprocal of I. Okay, so this is r. You might not see it. So over here is, you see the unit. So in the x-axis are reciprocal of r I, and the y-axis are r. So from this graph, he could use the intercept. Okay, so the intercept over here would be internal resistance. But if he use another set of data, okay, which is current and voltage, okay, and those are the data, and he could use the gradient over here to calculate the internal resistance. Now, this is how he analyzes, okay? So the intercept in the first graph is very small. Okay, if we look at the graph over here, intercept is very small. So any changes in the best fit will give a big percentage changes to its value. Okay, if we look at the graph, because intercept very small, so if you alter or if you change your best fit, right, and then the internal and the intercept will change, will have a huge effect, percentage effect on the internal resistance. So this will cause a big uncertainty. The value obtained from the first graph is this one, 0.35R. If we compare this with the value from the second graph, which is this one, we see that within the uncertainty of the experiment, they agree the second method based on the gradient of the line be the most reliable. Okay, you see over here after some quantitative and qualitative and mathematics analysis, and he had made a conclusion that the value obtained from the second graph, which is 0.44, is more reliable conclusion to give a value of R. Okay, but of course for our IA, we usually do not ask to measure the value, right? But this is just an example to show you that how you use the data and how to use the limitation, okay? How you discuss the limitation of the data to talk about the reliability of your conclusion, okay? This is kind of a challenge part, but you could try this if you wanted to get a 7 mark, and then I'm not going to talk about the other one over here. It's follow the same idea, okay? So first part, that's first part we talk about, using uncertainty, using your data, using your limitation of the data, right, to talk about reliability. Now, the third criteria is provide a logical and physical-based explanations for the train and result. So we use our data, and we have the train, we have the result, right? Now, right now, we need to provide some logical and physics-based explanation. So what is this physics-based explanation? It is the theory, which is the second aspect we talk about, right? In the first aspect, we talk about using data. Now, the theory over here, we actually have done this in the hypothesis, right? Hypothesis. When we talk about design, And we actually have to talk about how you're supposed to do your hypothesis. And in your hypothesis, you should have some theoretical derivation, and this is physics-based explanation. So if you have done this in the hypothesis and you just need to quote the hypothesis in the conclusion and to compare whether your hypothesis or support your conclusion or whether your conclusion is has some disagreement with your hypothesis, right? And then you have some further discussion if they are not consistent and which one do you think is a more reliable one, okay? And that's the second aspect of the justification that you use the theory. If you have not done this in the hypothesis, in the introduction or background, then you could also do it. You could also divide it or explain it over here in the conclusion part. This is not a typical example. This is just a kind of patterns, okay, that I create for you to follow. If you have no idea what you should write to justify your conclusion, and you could follow these patterns, okay? And after you go through this pattern, and you will see that what you should have write. You might not include all of that. Depends on your experiment. We could take a look at this very quickly. Okay, so say when you have your conclusion, and this is what you could say. As indicated in the graph, the relationship, blah, 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 okay, you show the pattern, right? Relationship shows a function of blah, blah, blah. This shows what kind of function, a linear or quadratic or logarithm function with some coefficient of what? This means physical meaning, right? So the y-intercept of the graph is how much? And this means when there's no speed, okay, I'm using my example is speed and stopping distance, okay, stopping distance. So my experiment is say how the velocity affect the stopping distance. If there's no speed, the stopping distance is, this is apparently not the case in reality. It could be causes by what? So the systematic error, that means there's a systematic error, right? And you could also talk about how the systematic error is going to be modified. And then after that, you could talk about uncertainty of your best fit line, right? And this means that blah, blah, blah. So as whether the train stay the same outside the range of my data. So after you have discussed your uncertainty and have a general conclusion, and then you could also talk about whether your conclusion stay the same outside the range of your data. Because when you, in your design, when you have your data and your data is within this range, right? And that means your conclusion is derived from this range of the data. Now, whether the conclusions still follow the same patterns, same train, outside the range of your data, and you could also discuss to discuss whether it will make it a general conclusion or universal conclusion, right? The conclusion follow the same train as derived in the hypothesis. So here you compare your conclusion with the hypothesis, right? Whether they will follow the same patterns or not the same patterns. If they are not the same pattern, they are not agree each other. And this could be the reason that whether in the hypothesis we ignore impact of friction. Now, if we consider the friction, then the relationship above is reasonable in the reality. Okay? In conclusion, this function can be used as the reference of how stopping difference, blah, blah, blah. In conclusion, final conclusion. Okay, so this is final conclusion, but this final conclusion by far is actually not so important. The important one is how you analysis, right? The important one is this whole paragraph. That how you use your data, you use your theory, you use uncertainty to justify your conclusion. Okay, and then the last part. The last part is research. Okay, so you have justify your conclusions through your data, and you justify your conclusions through the theory, and this is your research. All right, as you can see from here, I'm not going to talk about the experiment now, but we could see this is his research, right? After he has the data and conclusion, and then again he has done some research, and you could see the in-text citation over here, a lot of in-text citation, and then from this research, and he had a conclusion from the research. This is one of the property of the rubber, and it proves that an increase in the surface temperature of the rubber will lead to an increase in its COR. So COR is a quantity that used to describe how a ball is bouncing. Okay, bouncing over here. So COR, if he is investigated how the temperature will going to affect the COR. If COR is different, then the ball will bounce, or the energy lost, the rate of energy lost over here will be different. Okay, so this is his question. And then after the research and the blue one, okay, I'm going to highlight here is the conclusion from the research. Okay, indicate that if there's an increase in T, there will be an increase in COR. And now he is using this PPVC. He's not using rubber, but the research that he did, the research paper that he found out is about rubber. Okay, and now let's see how he used this research to justify his conclusion. He say both rubber and PPVC, he's using PPVC, are polymer materials, so they will respond to the changes in temperature in a similar way, okay, which is supported by the result of my study. So he is using PPVC, and he stated that these two materials are the same type of material, so they were going to respond to the temperature in a similar way. And that it means this research has proved his conclusion as well. Okay, and that's how the train is compared with the theoretical expectations and models. Okay, so by far, and you have justified your conclusions from 3 aspects. Okay, and this is what you should do to get a good, to have a good mark, or for a good research paper, right? You need to persuade and convince your readers to believe that your conclusion is right. Okay, and the last one is talking about citation. We're going to see if I have time to video call a separate lessons about how to do the citation in the material. Okay, and that will be all for conclusion part, and I hope that this video is helpful, and we will see you in the next lessons. Bye bye.